Alright, let's look at the last part right here of 3.1c. This will be our third video here. This is a long section. Alright, we're going to try to find the equation of a parabola by hand. So I know that the equation for a parabola is of the form y equals ax squared plus bx plus c. And if I have 3 points, I can plug these points in for x and y and write 3 equations where a, b, and c are going to be variables I need to solve for. Then I can solve a system of 3 variables, a, b, c, and 3 equations. So you need 3 points to do this. Give it a try. Okay, so the first equation, the y is 9, equals a times the x is 1, so 1 squared, plus b times the x is 1, plus c. The second ordered pair has a y value of 7. That's 7 times 7 equals a times the x value is 2, so 2 squared, plus b times x, which is 2, plus c. And the third ordered pair has a y value of negative 15. That's the y, equals a times the x value is 4, squared, plus b times the x value is 4, plus c. Okay, I'm going to take all 3 of those and rewrite it to make it look a little prettier because we don't like numbers on the right-hand side of our variables. So I'm actually going to move those numbers, the y values, to the left-hand side, or the right-hand side as well. So first of all, 1 squared is 1, so that'll be 1a, plus b times 1 is b, plus c equals 9. Just reordered and simplified this equation, right? A plus b plus c equals 9. Then 2 squared is 4, so it'll be 4a, plus 2b plus c equals 7. And then 4 squared is 16, a plus 4b plus c equals negative 15. That looks a little bit better. It's more in a standard form for a system of 3 variables and 3 equations. So we're going to be solving for a, b, and c. Alright, now I can choose any 2 equations to get started and any variable to eliminate. Since the c's all have coefficient 1, well, let's get rid of c. So I'm going to use the top 2 equations first, and we're going to eliminate c. Alright, so I just need to multiply one of them by a negative. How about the top one, because it has smaller coefficients of its variables? So let's use negative a minus b minus c equals negative 9. We're just taking a negative 1 times everything in the top equation. Negative a, negative b, negative c, negative 9. And we're going to leave the 4a plus 2b plus c equals 7 alone. Add those up. Negative a plus 4a is 3a. Negative b plus 2b is plus a positive 1b. And the c's eliminate. Equals negative 9 plus 7 is negative 2. Okay. In our next step, we're going to eliminate c in 2 other equations. So I suppose that I will choose the top equation and the last equation this time, so that I can multiply by negative 1 again and have a quick multiplication there. That's going to be my second step. So for second step, we're going to eliminate c again, this time with the top equation and the bottom equation. So that will be negative a minus b minus c equals negative 9. Again, I'm using negative 1, c, to add to the positive c. So you need to multiply by negative 1. And then we'll have our 16a plus 4b plus c equals negative 15. Let's add those up. Negative a plus 16a is 15a. Negative b plus 4b is plus 3b. The c's eliminate. Equals 9 plus 15 will be negative 9 plus negative 15 will be a negative 24. Okay. Okay, in step 3, we're going to be working with these 2 equations together, and we need to pick a variable to eliminate. I could do a If I wanted to use a least common multiple of 15, I can multiply by 5 and get 15. Or if I choose B, I can use a least common multiple of 3. I can multiply by 3 and get 3. So that sounds like a better choice. Less large numbers. Sounds good to me. So I have a positive 3b here already. We're going to want to multiply by a negative 3 to create a negative 3b. So let's do that. This is our step 3. I'm going to eliminate b. All right, with a negative 3, that'll be negative 9a minus 3b equals positive 6, right? Negative 3 times 3 is negative 9. Negative 3 times 1 is negative 3. Two negatives make a positive 6. Okay, we're going to not change this one at all since it already has a positive 3b. Just going to copy it over. So 15a plus 3b equals negative 24. Now we need to take 15a minus 9a is positive 6a. The b's eliminate, and then I have 6 minus 24 is negative 18. And then I can divide both sides by 6. And we get an a value of negative 3. Negative 18 divided by 6 is 3. Negative 3. Okay, now that I have an a value, I can go back into either one of these to solve for b. Probably going to choose the one with the smaller values, so we'll use that to solve for b. So 3 times negative 3 plus b equals negative 2. That's negative 9 plus b equals negative 2. And if we add 9 to both sides, we get a b value of 7. Okay, so I've got an a value and a b value. Now we head back into one of our original equations and go for the c value. Smallest number is in the top line, so we'll use the top line. A plus b plus c equals 9. Okay, so we have an a value of negative 3 plus a b value of 7 plus c equals 9. Negative 3 plus 7 is 4 plus c equals 9. So if I subtract 4 from both sides, we'll get a c value of 5. All right, so we know our a, b, and our c value. If we remember, our a, b, and our c value are the coefficients of a parabola that we were looking for. So instead of answering with an ordered triple, we're going to answer with an equation that has the ax squared plus the bx plus the c. So our final answer is going to be the equation y equals a, so negative 3 x squared plus b plus 7 x plus c, 5. Those 3 ordered pairs are all solutions to this parabola, this quadratic equation, negative 3x squared plus 7x plus 5. So we could check it if we wanted to by putting any of the ordered pairs in for x. Make sure you get the y value. So we want to test it just for one of them. If we look at negative 3 times, the first one was 1 squared plus 7 times 1 plus 5. The y value is 9. Good. We can check the others as well. Negative 3 times 2 squared plus 7 times 2 plus 5. That y value is 7. Perfect. I'm sorry, my light reflected that. Couldn't really see. And then the last one, negative 3 times 4 squared plus 7 times 4 plus 5. The y value was negative 15. They all check. Perfect.